Hi, my name is Eric Eide, and I'm going to tell you about discovering deep programming language bugs with Xsmith. So this is a talk about random testing of programming language implementations towards finding deep bugs. Let's dive into these three parts. So this slide shows you sort of the overview of a random testing procedure. Up at the top, we generate a random input using some kind of tool, and we provide that to the thing that we want to test, called the system under test. We decide, looking at the output or the behavior of the system under test, whether or not the output was correct. Did we get the right answer? Did the system crash? These are the kinds of questions we might ask. If everything works okay, then yes, great, our system seems to be working fine. We can go back and generate another random input. But if our system misbehaved, then we've found a bug, and we can dive into that using other tools, right? So in this particular talk, of course, I'm interested we're going to use Xsmith to generate our random inputs, and the things that we're going to test are a variety of programming language implementations. So let's look at this sort of idealized compiler or interpreter pipeline where we have a random input over on the left and we execute our program on the right. And we're interested in finding inputs that cause the program, when it's executed, to produce wrong answers. This is what we're going to call deep bugs. Okay, so what kind of input should we generate in order to find these deep bugs? Well, one thing we could do, we could start by just generating random byte sequences. This is not very good because most random byte sequences don't look anything like programs, and so we're not going to get very far through our pipeline. All right, so we can improve this. We can try to generate token sequences, things that we know are in the language that we're testing. This gets us a little further down our pipeline, but these things still don't look very much like programs. We're not going to get past the parser. Right? So we could try to generate grammatically correct inputs, things that look like they are C programs. This is getting better. We're moving down through the pipeline, but if you look, we're still not getting all the way through because the things that we're generating have serious problems. For instance, in this snippet, Y isn't declared, and we're trying to dereference an integer and add it to a string. This isn't going to make any sense. We're not going to get to execute this program. So we could improve upon this. We could generate statically correct programs. So now we actually get to execute these things. But the problem here is that these programs maybe don't have meaningful answers that allow us to decide whether or not the compiler was right or wrong. So imagine that the function f here produces a giant number, and we index off the end of the array. In C, that's an undefined behavior. We don't know what the answer is supposed to be. It could be anything. And so we can't really tell whether or not this program produces a right or a wrong answer. So what we need to do is we need to produce dynamically correct programs, things that have all these properties. They are correct programs, but they need to avoid unwanted behaviors at runtime. And these are the things that are going to allow us to detect deep bugs. So Xsmith is a Racket tool for creating random program generators, and it consists of two parts. The first part is a domain-specific language that allows you to describe the language that you want to generate. So it has facilities for describing the language's grammar and its scoping rules and its typing rules. It has ways that you can describe language features that you could like turn on or turn off. Say, I would like to use pointers, or I'd like to not use arrays, or I'd like to use this particular bit of the library or something like that, right? There's also controls in the DSL for describing how random choices get made during random program generation, and ultimately, of course, we have to output our program, so you have to be able to say how to print programs, right? The second part of Xsmith is a library of common reusable language parts. So these are things like loops and function calls and just things that are so common in different languages that we provide them as sort of prepackaged language definition parts that you can incorporate into your own random program generators, making it easier for people to use Xsmith. So the goal of Xsmith is to make it easy for people to create these kinds of high quality random program generators so that they can find deep bugs, right? So this is our research project. How are we trying to evaluate whether or not we're actually making things easy? Well, we've implemented a number of program generators for the languages shown on this slide, and the ones that are in boldface are ones that we've put some serious effort into. Okay. Another way to measure easy, of course, is by lines of code. And so a while ago, I was involved in the creation of a random program generator called Xsmith. It generated C programs, and the implementation of Xsmith is 43,000 lines of C++ code. So it's a little bit hard to compare that to the Racket implementations of Xsmith and the various random program generators that we've made with it. But in general, you can see that the line counts here are much smaller, suggesting that we are in fact making it easier for people to create these kinds of random program generators, and a variety of random program generators, not just for one language, but for whatever languages people want to test. So let's talk about a couple of Racket bugs, or a couple of bugs that we found with Xsmith. So the first one is a bug that we found in Racket. This is a bug in Racket 7.9. And on the program shown on this slide, in Racket BC, right, the answer of GCD, it returns that giant negative number, but GCD is documented to always return a positive number. And so Racket CS correctly returned the positive number. This program is the simplified version of the random program generator that was made with our Racket kernel fuzzer. We reported it and it got fixed really quickly. Something that was interesting about this is that Matthew Flatt said that this bug was at least 20 years old when we got to report it. So, all right. The second bug I want to tell you about is we found with our WebAssembly generator. So this is a bug in a WebAssembly implementation called WASMer. It has two different compilers, one called Crane Lift and the other one is based on LLVM. And this program on the right, the correct answer is 235. But when compiled with the LLVM compiler, the incorrect answer was -1. So we reported this to the WASMer developers, and they seem to be appreciative. One of the developers said that this is a great bug. So we're still actively looking for more bugs in WebAssembly implementations. So just to wrap up, Xsmith is a tool for creating high-quality random program generators. You can install it from the standard Racket package catalog. It comes with substantial documentation. It comes with a variety of example program generators. If you'd like to try it, we have a support mailing list, but I want to caution you that this is a research project in progress. So things might not always work just like you'd like them to, but we are interested in working with you. So please let us know. Thank you for coming to my talk.